Hello everyone, welcome again in Eng-Man YouTube channel. So we'll continue our learning on PVTP software for compositional oil modeling. And in previous video, we have achieved, relatively speaking, good, matching for GOR, for liquid density, as well as for the saturation pressure. Although we still have room to improve the quality of the matching. For example, if we open this, separator train, result stable, stage result, you can compare the stage GOR 708 with the lab data. And then if we expand the oil density, you can compare the 835 kilogram per meter cube for oil density predicted by the model, by the equation of state, compared really good, quite good, with the laboratory data, which is 814. But of course, we still want to further improve the quality for the matching, all right? And to get a feel for, how to get the better matching, of course, we have or we can adjust like the molecular weight of the pseudo properties or specific gravity of the pseudo properties, pseudo component, or the boiling point temperature. And to get a feel for how the molecular weight, specific gravity, and boiling point temperature affect the spirator and phase envelope calculation, we can do something like change one parameter at a time. You can change at a time the molecular weight, or you can also, change the specific gravity, or you can directly change the boiling point temperature. Okay, so first you can change one parameter at a time, and then you recalculate the pseudo properties data object, and then you recalculate all of the calculation objects. Okay, so first change one parameter at a time, recalculate the pseudo properties, and recalculate all the calculation objects. So that's one thing that we want to know and we want to do in this. I hope we can wrap up this as a simple video. All right, with that said, we want to try to achieve as close a match between the measured and calculated liquid density and GOR by changing the molecular weight and specific gravity only. For this, we can do these following steps. First, we will change a parameter in the pseudo properties. And then we will press this calculate button to estimate the boiling point temperature as well as the critical properties, and ensure that the auto match option is enabled to ensure that the calculated liquid phase density is realistic. And remember, we use standing cuts for density method. And then we will press calculate objects to recalculate all the calculation objects, including separator train and phase envelope, okay, for quality matching by clicking this button. So after you click on this calculate to recalculate pseudo properties, you can press calculate objects to recalculate everything under this calculation wizard. So we can recalculate everything at once for this calculation section on the right side. Okay, and you can repeat if necessary. Okay, so first, change a parameter in the pseudo properties. For example, you can change the molecular weight, you can change the specific gravity. You change that, and then you press calculate to estimate the boiling point temperature and critical properties. Make sure that you enable, not enable, but enable the auto match. And after that, because you change the pseudo properties, you need to recalculate everything here. And you can do all at once by clicking this calculate objects. Okay, and repeat if necessary. Of course, we want to achieve better and better matching. Okay, so one possible scenario that I just want to do now directly is, let's say, instead of molecular weight of 220. We want to, change it to 230. And instead of specific gravity of 0.87, let's change it to 0.85. Okay, and then make sure you keep it as it is, the enable auto match, and calculate. Okay, so we get this calculate boiling point temperature, very good, as well as the, critical properties. So again, let's try, and you can follow me, molecular weight of 230 and specific gravity of 0.85. Click on OK. You see here, because we changed the pseudo properties, we need to recalculate this too by including the change, the molecular weight and specific gravity. And it doesn't matter, it's not difficult because we can do all at once by clicking this calculate object, and you see they are already calculated now. By the way, we need to check the last error. Okay, so the error is good, minus 0.06% for the liquid density, good. Okay, and let's check the separator train. You can recalculate if you want. Result stable, stage result. Now the stage GOR becomes closer to the laboratory data, which is 661. Now we get 665 SCF per STB. So it's closer compared to our first matching. And that's for stage GOR. Now we go to oil density. The lab data gives us 814, now 820, which is of course even closer compared to the previous estimation, which is 835. Okay, so that's good. And lastly, let's check the phase envelope. Results plot. You see, we still, a little bit greater or above. Oh, sorry, we are still below the lab data. Okay, and thus we need to do something else to achieve better match. So although the GOR is good, liquid density is good, and then, yeah, both of them are good, we are not that satisfied because the bubble point pressure or the saturation pressure is not that good. All right, and we will do further improvement, but that's a topic for another day. In that case, we will do pseudo splitting, and we will expect that we can better match, especially the saturation pressure, by keeping the GOR and density still with very good matching. Okay, so until then, see you and thank you.